Hisashi Hayashi. Thank you for your introduction. I'm very happy to be able to talk to you today. Today, I want to talk about study on study on reinforcement of tunnel lining concrete with carbon fiber sheet using numerical analysis. My presentation is in 6 parts. First, I'm going to talk about background purpose. Second, about the carbon fiber sheet. Then I would like to talk about assumed external force factor. After that, I'm going to numerical simulation and result discussion. Finally, I will summarize. I'd like to start by talking about background to study. This slide shows it is about the road tunnel stop in Japan. In Japan, many road tunnels were built after the 1970s. The deterioration of these tunnels is a problem in Japan. Deformation due to material deterioration has been reported in this tunnel. In addition, there are many reports of deformation cases by external forces from the ground. These deformations are often found in tunnel constructed by conventional method. Among them, this study focuses on the external force from the ground. In this study, the repair effect was simulated by numerical analysis. Black 3D was used for numerical analysis. First, we simulated deformation due to an external force. Next, we conducted verification of the function and effect of reinforcement work in each deformation mode. Also, many tunnel reinforcements have been proposed. In this research, we focused on reinforcement by carbon fiber sheet and performed simulations. In this section, I'm going to talk about carbon fiber sheet. Carbon fiber sheet construction in tunnels is done in the order of primer, undercoat, carbon fiber, top coat, and protective paint on the lining concrete. Tunnel lining concrete is plain structure. The carbon fiber sheet improves the tensile strength. This slide shows load conditions acting on lining concrete. These are 2 load conditions simulated in this study. Case 1 simulated a vertical load. A local load with a diameter of 0.3 meter act on the tunnel top. This is a load acting due to loosening of the ground. Case B. On the other hand, is vertical horizontal load. In case B, 1 meter wide load act on the tunnel lining. All these loads are directed inside the tunnel. Such load are caused by the presence of fault planes around tunnels and sudden load cases by earthquake. This slide shows a numerical analysis method for lining concrete. The mechanical model of lining concrete is a tensile softening model. Tensile softening occurs when the tensile strength of the lining concrete is exceeds. In addition, numerical analysis is performed in two-dimensional. The input parameters for the lining concrete are plane strength. The input parameters for the lining concrete are elastic modulus 25,000 MPa, Poisson's ratio 0.2, tensile strength 1.91 MPa. Next, interface elements were used to model the boundary between the lining and the ground. Model that separation when the normal stress exceeds the tensile strength. Also, when the stress in the shear direction exceeds the shear strength itself. A liner element was used for the carbon fiber sheet. For the carbon fiber sheet, the input value were set in consideration of peeling and frictional resistance between the fiber sheet and the tunnel lining. The input parameters for the carbon fiber sheet tensile stiffness 250 GPa, thickness 0.167 millimeter. Normal direction bond stiffness 10 MPa, shear direction 10 MPa. Normal direction bond tensile strength 30 MPa, shear direction 1.5 MPa. The following slides shows the result of numerical analysis. First, the analysis result of case A without carbon fiber sheet reinforcement. When a load is applied to the top of the tunnel, a tensile fracture area occurs. In addition, the tensile fracture area expands radially. From this figure, it can be seen that the crack propagation due to vertical load can be simulated. Next, the analysis results of case B without carbon fiber sheet reinforcement. In case B, the vertical horizontal load cases are slice-shaped tensile region. This slide shows the effect of the carbon fiber sheet in case A. And the plastic area of the lining concrete becomes smaller when the carbon fiber sheet is used as a countermeasure. The amount of the amount of strain also becomes smaller. In other words, cracks in the lining can be controlled by installing a fiber sheet. The slide shows the effect of the carbon fiber sheet in case B. Case B. The simulation result with and without the carbon fiber sheet are shown, but there is no difference in the plastic region and strain. In other words, cracks in the lining cannot be controlled by installing fiber sheet. Finally, I will talk about the summary. In this research, modeling and numerical analysis of lining concrete between lining and the ground and carbon fiber sheet were shown. As a result, confirmed the reinforcing effect to the vertical load by carbon fiber sheet. That's all I have to say. Thank you for your attention. Thank you for your question. Today's presentation, one case of loading. We have many case loading case. Okay. Sorry. The carbon fiber sheet so cross. Yeah, yes. Anchor. This simulation not use anchor. So just hold on. Sorry. Not only numerical analysis. I think in the experiment, the performance really. Okay, thank you.
Yeah, I'm gonna follow up with the idea of experiment. Your cohesive interface point here, but it never that kind of face plateau. So maybe an experiment would be useful to validate, because usually after the feature is soft, you have basically a drop in tension and a plateauing shear. Usually doesn't happen there for
very good. Thank you for your comment.